Two type.
Two type, 1 pair and 4 pair.
Wireless.
RJ11 and RJ45.
Guided and unguided.
Guided and unguided.
Wired and wireless.
Yes.
And what is the purpose of switch?
To connect devices
Through what?
to wired.
Through wired.
Yes.
So that's the main point need to be understand actually. Board switch, correct?
Yes.
Okay, then what is the purpose of access point? Wireless access point.
To connect devices wirelessly.
To connect the device through wireless, okay. What is the purpose of router then?
Enables connection between two or more networks.
Well, so router is a device which enables communication between two or more different networks. Correct? Yeah. Then what is the purpose of firewall?
It polices the traffic.
Yeah, firewall will protect our network from unauthorized traffic. We can write the policies in firewall to control unauthorized traffic, right?
Yes.
So these are the points. So we're done with the previous class and we start with the main point is basic requirements to build a network or to form a network. Can anyone tell a list of components? Point number one is NIC. Point number two,
Media.
media. Point number three,
Working devices,
networking devices. Networking devices are
switches, routers, WAPs.
switches, access points, routers, and firewall. And what is the fourth point?
Logical address.
Logical address. Fifth point is
IP.
Protocol. TCP IP.
protocol. So today we're going to start with the point number 4, which is logical address. Before starting to logical address, do you have any doubts regarding these previous classes? Both NIC, media, networking devices, those things. Hope everything is good. Yeah.
Quick
We'll
question.
continue.
For networking devices, you said that each organization, do they have multiple firewalls or just one firewall is good enough for the whole organization?
Multiple, like wherever network is there, like you have multiple sites, each site should have one firewall.
Okay, thank you.
So today we'll continue with logical address, which is IP address. Basically, IP address is our two terminologies actually. IP is one terminology, address is another terminology. We'll discuss later about IP clearly. Let's understand about address. Basically, what is the purpose of address? General question, general. In general,
Location.
address. If I know your address,
We can communicate.
I can communicate with you. I can reach out. I can trace, correct? Similarly, how devices can reach out to another device. How device one can identify another device. You are my destination. I want to communicate with you. Like this is FTP server, this is a mail server, this is a printer, this is like something. Some devices, how one device can identify another device, even between devices also must require an address to identify, to communicate, to reach out. That address we call IP address. So in simple, IP address purpose is identification and communication purpose. So these IP addresses are two versions. One is IP version 4, IP version 6. So today we'll focus on IPv4 in upcoming sessions. It might be tomorrow we'll discuss about IPv6. So let us focus on about IPv4 address. All of you following me?
Yes, sir. Yes.
Perfect. So I'm requesting to everyone again, this is very, very important session. I need your more focused on this session actually. IPv4 is 32-bit address. So bits means zeros and ones actually. So IPv4 address the combination of 32 zeros and ones. Let us take 32 zeros and ones and discuss actually. Okay. I'm just taking some random numbers like 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this is one 32-bit address. So this is one address actually, right? 32 combinations. This address, which is 32 address, the format is, it is in binary format, which is machines can understand this format. As a user, how we can understand, we need to convert it is into decimal format. So before understanding to convert, how to convert from binary to decimal, entire 32-bit of IPv4 address is divided into 4 portions, like first 8 bits, second 8 bits, third 8 bits, and fourth 8 bits. So each portion technically we call octet, like one octet, which is equal to 8 bits. Is a rule actually, is a logic. Okay. So similarly, 4 octets are 32 bits, correct? Okay. The next point is, so which is the first octet, which is the second octet, which is the third octet? Every octet is being separated by using a dot, like first 8 bits dot, because we need to differentiate something now. Even generally, if you see your website names, tell me any website name. www.google.com. So we are using some dot actually to differentiate www worldwide dot. So that our website is belongs to World Wide Web. And what is the website name? Google dot. What is it? Google is a commercial network or it's a dot in or dot co. Like so, we use some dots to differentiate something. Even here also, first octet, second octet. To differentiate the octets, we use dot. First octet dot, second octet dot, third octet. Like dots we used actually. Now let us convert from binary to decimal format by using the formula says 2 power n. 2 power n table, let us take action. Why 2 power, why 2 only is binary means 2, 0 and 1. A 2 power n can be a, so we need 8 bits, right? Because each octet contain 8 bits. Let us take 8 bits. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. 8 bits. The first one, second one, third one, 4, 5, 6, 7, 8. Got it? So 2 power 6. What's the value of 2 power 0? 1. Any power 0 is 1. 2 power 1, 2. 4, 8, 16, 32, 64, 128. Correct, guys? Yes. So first bit value is here the first bit value will be 128, 64, 32, 16, 8, 4, 2, 1. Okay. Even second octet also 128, 64, 32, 16, 8, 4, 2, 1. That is Mr. MD. Okay.
गैलेक्सी कहाँ पे है अभी? गैलेक्सी कितने गालिब क्या है?
Right. I have a control. I'll make it. Okay. Yeah. Done. So now logic is here 0 and 1. 0 indicates your bit is off bit. 1 indicates your bit is on. So now understand here. In first octet, which bits are on bits? Which bits are off bits? Leave it off bits. Let's see about on. Which bits are on? 64 is on, 32 and 4. So if you total it, 64 plus 32 plus 4, how much? 64 plus 4, 68 plus 2, 70, 73. So what is the total value of first octet? The 73. Dot second octet value. In second octet, which bits are on bits? 16 is on, 2 is on, and 1 is on. 16 plus 2 plus 1, 19. So 19 dot. Similarly, you try to calculate quickly for third octet and fourth octet. Tell me the values. Do it fast.
$41.
Third octet, right?
41.
Okay.
14, fourth one.
14. Right. So we got one address now. 73.19.41.14 is one IP address. So this IP address we can use to assign any one of the device. 73.19.41.14. Like I'm giving some examples of IP address, like 121.19.23.56. So you can give me your examples also quickly. Anyone, please.
192.
Everyone.
192 dot
192 dot
168
okay.
dot 10 dot 1.
Next.
192.160.17.1.
Okay. Yeah, I need a very big list. Give me anyone. Everyone one IP address.
192.168.0.101.
0.101. Okay. Is my voice is low?
No, perfect.
Okay. So let me give my examples, like 178.189.23.78, 186.9.2.1, 19.13.167.19, 200.23.19.67, 172.16 or dot 17.10, 2 to the 234, 224.9.9, 2059, and just some random numbers I'm using here. Okay, 223, 45.19, 242.7.89.145. So like this, I'm making some very big list. Okay, guys, I'll back to this list later. We'll continue with this point. So this is how we can convert binary to decimal format. But now we need to understand in IPv4 total how many IP addresses are available. Like how can come to know total the range of IPv4 address? Simple. IPv4 address space. How many bits IPv4 address? Bits means what? 0 and 1. In zeros and ones, which is the least bit? 0. Which is the highest bit?
1.
1. So if you write all 32 zeros, starting combination. If you write all 32 ones, is a maximum combination. Then we can get the range of IP address now. So let me write a least, first octet least. What is the first octet least? 8 zeros.
Zeros.
1, 2, 3, 4, 5, 6, 7, 8. Dot is the first octet least. Correct? Second octet least. Third octet least. Fourth octet least. It's 4 octets. The starting combination of IP address. What is the maximum combination?
All ones.
1, 2, 3, 4, 5, 6, 7, 8. The maximum first octet highest, second octet highest, third octet highest, fourth octet highest. So we got highest value also is the maximum combination of IP address. Agree?
Yes.
Yeah. So we know that what is the first bit value? 128, 64, 32, 16, 8, 4, 2, 1. Here also 128, 64, 32, 16, 8, 4, 2, 1. Same like second octet, third octet, fourth octet. 0 indicates what? Off. 1 indicates?
On.
On. Here all are off bits. Then it is 0. Dot. Second octet? 0.
0.
Third octet?
0.
Fourth octet? What about highest? All are on. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. If you total it, value will be
255.
255. Dot. Second octet?
255.
255. Third octet? 255. 255. So IPv4 address range is 0.0.0.0.2 255.255.255.255. This is total range of IPv4 address. In between we have 4.3 billion IP addresses, which is a combination of 2 power 32 combinations. So total IPv4 addresses are 4.3 billion IPs are available actually. Okay. Right. The next point is all 4.3 billion IPs are classified into 5 classes. Like class A IP addresses, like class B IP addresses, class C, class D, and class E. So why they classified? Because of each class there is some different purpose actually. So class A IPs are class B, class C. ABC IPs are reserved for the purpose is to use in local networks and wide area network. So ABC classes IP's purpose is LAN and WAN. And class D IPs we cannot use actually. Class D IPs are used for what? Multicast. Even class E also we cannot be used for computers assignment. Class D is reserved for R&D, research and development purpose. So like this IP address is classified different purposes. Got it? Now back to this list of IP address. So first one, if you see first one, 73.19.41.14 IP address. For what purpose I can use it? So is it for LAN and WAN purpose or multicast purpose or R&D purpose? What purpose first IP address is reserved?
LAN and WAN.
How we can say the LAN and WAN?
There is a ratio of IP address. I think it's
So now we need to understand by seeing IP address, we need to identify the class. So and so IP address is belongs to so and so class. Is it class A or class B or class C, like that actually. If you know the class, then we know purpose also. Agree?
Yes.
Yeah. So how to identify the class? That is our first target now actually. Every class A, class B, every class there is certain range actually. So based upon the range, we can identify the class. What is class A range? So total IPv4 range is this, we know that 0002 to 255. From that, class A IPs are any IP starting with 0 to 127. 0 to 127 IPs are belongs to class A. Similarly, 128 to 191, any IP starting with 128 to 191, these IPs belongs to class B. Okay, all of you following me?
Yes. Yes.
But you can ask me the class question. Okay, Balu, you are telling good, but what is the logic behind for class A 0 to 127 only? Why not some other number 0 to 20 or 0 to 120? Huh? So what is the logic behind of 0 to 127 only for class A? For class B 128 to 191? What is that logic actually? Is all the classification is done based upon the priority values, based on priority bits. Priority bits. You can see this point about priority bit. This is IP address are divided into 5 classes and ABC purpose D and E. Priority bit. Priority bit is used for IP address classification. Most significant bits from first octet are selected actually. So for class A, first bit 0 is reserved. For class B, first 2 bits 1 0. For class C, 110. For class D, 1110. These all priority bits are reserved fixed. Okay. So class A, first bit 0 is reserved. For class B, 10. For class C, 110. 1, 1, 1, 0, 1, 1, 1, 1. So based on these priority bits, this classification is done actually. I'll explain it clearly. Is all priority bits are reserved from first octet. Let me take first octet value. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is a first octet. Agree everyone? All of you following me?
Yes, sir.
This is the first octet, right? So from this first octet for class B, how many bits are reserved? For class A, how many bits are reserved? 1 bit. What is that? 0. For class B, 1 0 means 2 bits. For class C, 1 1 0 means 3 bits, like this. So here, first bit 0 is reserved, means first bit should be 0. It should be 0 on both. Here should be 0, here should be 0. Let me make it as a 0. This is 0. This also should be 0 actually. Done. First bit reside as a 0. Correct? All of you.
Yes, follow.
Yeah. So for class B, first 2 bits should be as 1 0. So 1 0, 1 0 like this. For class C, first 3 bits should be 1 1 0, means 1 1 0, 1 1 0 like this. So first let's understand about class A. For class A, 0 is reserved. 0 is reserved, done. Now convert this into decimal. How to convert to decimal? 128, 64, 32, 16, 8, 4, 2, 1. All are zeros. Means what is the value?
0.
0. Here, if it is all are ones, understand it is also 1. Consider it is also on 1. If all ones, then
255.
255. But first bit is 0 now. So what is the first bit value?
28.
28,
Then do minus 128. Value will be
7.
127. That's 127 dot. So 0 to 127. From first octet value, second octet 0 dot 0 dot 0. Highest second octet 255. Highest 255. So this is total class A range is 0 dot 0 dot 0 dot 2. 127, 255, 255, 255. These are in between all IPs comes under which class IP address we call? Class A. It's clear, everyone? This is how we can classify actually.
Can you explain one more time, please? Don't mind.
Yeah, sure.
Thank you.
So let us take for class B. See, class B, I just used least and highest numbers. Okay, first octet least and highest. Now for class B, how many bits are reserved? 2 bits. So first 2 bits should be 1 0. First 2 bits should be 1 0. First 2 bits should be 1 0. First 2 bits 1 0. Done. That's all. This is 1. It is 0. 1 0 1 0. Done. Convert into binary. That's all. What is the first bit value?
128.
128. It is on now. Continue to consider. So 128 is the value. Remaining all are off. Here, if all are on, consider it is also on. Then value is what? 255. But actually it is off now.
64.
Second it is off. Means minus 64. What is the value? 191. So it is 191. So 128 to 191. 128.0.0.0, 191.255.255.255 maximum. This is total range of class B. 128.002, 191.255.255. It's clear now? So similarly, you calculate and tell me the answers for class C range, class D range, and class E range. Do it fast. Yes. Class E 110. Sorry, class C. Class D 1110. And class E 111.
Class C 192 to 223.
Okay. 192 to
223.
223. Perfect.
Class
Okay.
D 224 to 239. Class C 240 to 255.
Okay. So class C range is 192.
60.
192 to
223.
192.0.0.0 to 223.255.255.255. That's class C range. What about class D?
224 to 239.
Nine dot 255.
And class E range?
240 to 255.
240.0.0.0 to 255, 255, 255, 255. This is completely 0002, 255, 255. Got it? So we got to know. So which class IPs belongs to? What is the range section? Correct? Yeah, these are ranges IP address. Now try to find it out. So which IPs belongs to which class based upon the range. Now we got the range, right? So first IPs belongs to which class?
Class A.
Next one, 121.19.23.56.
A class.
Class. Class A.
Next, 192.168.
Class
Class B.
Class?
C.
Class?
C.
192.
C.
Next is also 92. C.
Class C.
Next also C.
Class C.
178.
B.
Class B.
B.
Class B. 186.
B only.
B.
19.
A.
A.
200. 23. 19.
B.
67.
C.
C. C.
172.17.
B.
Class
B.
B. Yeah. 224.19.
It's D.
So this 224.19.59.17 IP address, can I use this IP address to assign to computer?
No, sir.
No, you cannot use actually, because this IP is reserved for what purpose?
Multicast.
Multicasting. So which class IP address is only we can use?
C.
ABC
C.
only. So this IP address we cannot be used actually. Like any IP address starting from 224 to 239, we cannot be used. Like 223, can we use 223.19.45.19? Yes. So then which class IP it is belongs to? It's a class C. Yeah. Next one, 242 is a class E. Research and development. Even this IPs also cannot be used. The last example belongs to which class?
1.
Class?
Class D.
D.
Class C.
Invalid.
Invalid. Why it is invalid?
Because 256.
Because of 256. So how 256 we can get in IP address? What is the maximum number?
255.
And how 256 we can get? So it's invalid IP address. Okay. Yeah. So like this we can identify which IPs belongs to which class and what is the purpose. Again, have one more task, quick task. Try to answer it. Identifying classes. This is the list of IP addresses. Quickly tell me answers. First one.
A.
Next.
C.
C.
A.
C. Next.
E.
D. Next.
B.
A. 120 is A.
Yeah.
Next 150.
B.
B. Next.
Invalid.
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 Oh, excellent.
256 is there.
Invalid IP address. Good. Okay. So next logic is port V4. Here has few devices. Device 1, device 2, device 3, 4, 5, 6. All 6 devices are interconnected with switch with RJ45 cable. Like what we call this is?
Network.
It's a network. Okay, because interconnection of 2 or more devices we call network. Now how device 1 can identify with device 2? So how devices can identify and how they can communicate? What we need to do?
My virtual
IP.
machine.
See, my question is very simple. How devices can identify one device to identify device, how they can identify what they need?
Switch.
IP addresses.
IP address.
IP address.
So for this network, which is having a 6 computers, which class IP address do you recommend to use? Class A,
IPv4.
class B, class C, class D, or class E?
Class C.
C.
We can't use class E. We can't use class D.
C.
So answer is what? ABC. From ABC, again, which class is recommended? A or B or C?
B.
Why not A? Why not B? Why not C?
Yes.
So here, how many devices are interconnected?
6.
a device in a network. A device in a network called host. So IPv4 address is divided into networks and host portion. See the octet format of class A. First octet is the network portion actually. N means network portion. Second octet host. Third octet host. For class B, first octet is network portion. Second octet also network portion. Third octet is host. Fourth is host. For class C, first octet is network portion. Second octet is network portion. Third octet is network portion. And fourth octet is host portion. It is fixed actually. I mean default. By default, this is a network and host position. Now our requirement is we need a 6 hosts, right? A host requirement. How many hosts we need here? A requirement is 6. Very few number of hosts. So which class is recommended?
A.
Why in class you have many networks portion? Many networks are available now. Sorry, many hosts are available now. But the requirement is very few number of hosts. So where you can get few number of hosts? In A, B, or C?
C.
C.
Class C.
C.
So class C is recommended. Like based upon our network requirement, host requirement, we need to use A or B or C actually. General example, Geo network. Network is one, but how many customers are connected?
Millions.
Millions of hosts actually. So then which class is recommended?
A.
A. Class A. Like in the banking sectors, is the largest bank, SBI, is one network, but how many sites and how many equipment and how many branches, very huge number of hosts. Which class is recommended?
Yeah.
Yeah. Okay, railways is the largest network, right? So more number of host requirement. Which class is recommended? Yeah. Like if it is a home network. So hardly how many devices do you have at home?
1 or 2.
So hardly 5 to 10 devices, because nowadays almost you're using smart devices, right?
Smart TVs and everything.
Yeah, so 5 to 10 devices consider. Since 5 to 10 devices, then which class?
Class C.
Yeah, just a minute. Yes. So based on our requirement, it can be a network requirement, it can be a host requirement. Based on our requirement, we can use A all, B or C action. Got it? See, for home networks or small networks, which class IP is recommended? Class C.
C.
What is the class C range? Class C range.
One start with
to 223.
Start with 192.
two.
See, that is why many people give many example 192, 168, 192, 192. Because we are very familiar with 192 IP address. You know why? We connected to home networks and we connected to small networks. So once you got chance to work with a corporate networks, then you can get the chance to work with A and B classes IP address also. Got it?
Yes.
Yeah. But my requirement is now networks I need. I need 100 networks. And tell me which class do you recommend to use? A, B, C. The requirement is 100. Class B.
C.
Why? C. Why?
Because
Because
255 host layer.
you may be thinking 100 is more networks, so we can see more networks in class C. Is it like that?
Network. Okay.
So we don't know. Thing is, we don't know how many networks in class A. We know first octet portion is network portion. First 2
Five.
octets are class B. First 3 octets are networks, but we don't know the number actually. Correct?
Yes, sir.
Let us calculate how many networks in A and B and C. Similarly, how many hosts in A and B and C. Okay. Remember priority bits. For class A, how many bits are priority bits?
1 bit 0,
1 bit 0. Yeah. For class B,
1 and 0. 2
means 2
bits.
bits.
Yeah.
2
For
bits.
class C,
3 bits.
110.
3 bits, which is 110. Okay. Thanks. Each octet contains how many bits?
8 bits.
First
8.
octet is 8 bits. Second octet, 8 bits. Third
8.
octet, 8 bits. Fourth octet, 8 bits. So in class A, total number of network bits. Total number of network bits are 8. 8 bits. These are network bits, right? N means network bits. Total number of host bits in class A. Total number of host bits. 8 plus 8 plus 8. 24. 24 host bits. Total number of network bits in class B. 16. Total number of host bits in class B. 16. Total number of network bits in class C. 24. Total number of host bits in class C. 8. Is it clear till? Right. Now we are going to calculate about how many networks on each class. So number of networks is our calculation. So you have one formula to calculate number of networks, which is 2 power number of network bits minus priority bits. Of 2 power number of network bits minus priority bit. Just keep in mind this point actually, formula. Yeah, done. 2 power number of network bits minus priority. So let us implement the formula for each class. Same. And starting with class A. All of you, anyone, can you open your mobile calculator and do some quick calculations? Class A, 2 power number of network bits. How many number of network bits in class A?
8.
Minus priority bits. How many priority bits for class A?
1.
1. So 2 power 8 minus 1, 7. 2 power 7 value?
128.
So finally, how many networks are in class A? 128
128.
networks. So now we got idea now. Oh, class A having 128 networks. Like this, we need to understand in class B and class A also. But thing is, in class A, all 128 networks are not in use actually. 2 networks are minused. So how many networks in class A? 126 networks. But here you can ask me the question, why Balu 2 minus 2, right? So why 2 networks are minused? So which networks are minused is, what is the range of class A? Class A range is 0 dot
To
0 dot
127.
0 dot 0
20.
to 127. So these 000 networks cannot be used actually. This is for identification. We call this global ID. It is global identification. Means all 4.3 billion IP addresses will be identified by ID called global ID, which is 0 dot 0 dot 0. So we call this what? Global ID. So this is one network minused. Similarly, 127 network. 127 network is also minused. We call it is loopback ID. Loopback ID. So this loopback ID purpose is to test TCP IP stack, like whether TCP IP is working or not. What people generally can do, they used to open the command prompt and you can
Yeah.
use ping 127.001 or 2, any IP address. If it is getting reply means in your device TCP IP is working fine. So to test a TCP IP, there is one network is reserved, which is 127. We call it is loopback. So 127 network and 0 network cannot be used for computers. So why 2 networks are minused? One for global ID, one for loopback ID. Remaining in between, like 1 dot network, 2 dot network, up to 126 networks can be used actually. Okay. Between 1 to 126 networks are used. So minus T only in class A. Class B full networks. Class C full networks we can use actually. Is it clear? The dots?
Is 127.0.0, is that also called private IP address? Or is that different?
So can you repeat please what is question? 127?
Never mind. I got the answer. Never mind.
Okay, okay. Next. Global ID and loopback ID is done. For class B, for class B, 2 power number of network bits. 2 power number of network bits minus priority bit. 2 power number of network bits are
16.
16 minus how many priority bits for class B?
2.
Minus 2. 2 power 14. Yeah, please.
16,384.
16, 16,
384.
16384. Yeah. So 16384 networks are available actually. This many networks in class B. Here no minus 2. Global ID, loopback ID done in class A. That's all. So class B, total networks we can use actually. Class C. Class C, 2 power number of network bits are 24 minus priority bit is 3 minus 3, 2 power 21. Value please.
2097 152.
2097
152.
152. So these many networks are available in class C. Thank you, Aishwarya. So now we have one clear idea about how many number of networks in A and B and C. So in class A, 126 networks. In class B, this many. Class C, this many networks. So similarly, need to be calculated for number of hosts on each class. Okay. Let's continue with number of host calculation. For number of host calculation is 2 power number of host bits. 2 power number of host bits base minus 2, not power, base minus 2. That's all. Simple. It formula itself, it is a minus 2 here actually. Hence, for every network, there are 2 IPs are minused. I'll tell you why. Let us start with class C. Yeah. 2 power number of host bits. 2 power number of host bits in class C, 8, base minus 2. What is the value of 2 power 8? 256 minus 2. Right? 254. What is 254?
Host.
254? Host. What about 256? What is 256 then? What is 256? What is 254? 256 is number of hosts. But 254 is 254 host, usable host, valid host. So out of 256, 256 can we use? No. 254 only can use. 2 IPs are minused. So 254, we can say 254 valid host per network. For each network, there are 254 usable IP addresses in class C. In class C, how many networks? 2097152 networks are available. For each network, how many usable IPs are available? 254. Okay. Class B. Class B formula. 2 power number of host bits. 2 power 16 minus 2. What is 2 power 16 value?
65536 minus 2.
65,536 minus 2. So 65,534. What is 534? I mean 65,534 is what?
Valid host.
Number of valid hosts.
Number of valid host. Number of valid host per
Network.
network. Number of valid host per network. So class B, we have 16,384 networks. Then for each network, there are 65,000 plus IPs actually. Class A. See here you can see how many IPs you'll get it. Answer 2 power number of host bits are 24. 2 power 24 value. 2 power 24 base minus 2. So 2 power 24 is
16777.
16777.
216.
216 minus 2. So 16777, 214. 214 is 214. Valid host per network. So 16,777,777. 16 millions plus IPs are available. Usable IPs are available for each class per network, per each network in class A. Got it? So finally, we have a complete idea about how many networks in class A, networks in class B, class C. Similarly, how many number of hosts are available and how many usable hosts are available on each class. Clear? Any doubts? Yes, please. Yeah. Okay. So why you are not asking any questions? You can ask me here. One question is why? Why? -2 on each network. 2 IPs are minused. In number of networks calculation for class A, we do -2. 2 networks are minused. That is clear because one for network ID and one is a global ID and one is a loopback ID. But what about number of host calculation? In number of host calculation, 2 IPs are minused. Why? Any idea? Ten dot 0.0.0. This is one network, 10 dot network. And what will be the immediate IP address? What is the next immediate IP address? The next IP will be 10.1.0.0 or it's 10.0.0.1. How? What is IP address format? If it is brand new vehicle,
One.
brand new, so your reading will be zeros. You ride for 5 kilometers. So if you ride for 5 kilometers, where number will change?
Last one.
Last one. Here 5 kilometers. If number is changing here, then how many kilometers you ride? Huh? 5,000 kilometers actually. So numbers will change here like this. 5 kilometers. After 9 kilometers, then the next bit here will be changed. 10, 11, 12, 13. Like up to 99. If it is done 99, the next this bit will change, right? So similarly IP addresses also. So 10.0.0.0 next 10.0.0.1 next is 10.0.0.0.2 10.0.0.0.3 up to 10.0.456 up to 255 here. So 0 to 255 is done. Next third octet will change 10.0.1.0 10.0.1.1 1.2 up to 10.0.1.255. Next 2 will change here, 3 will change, 4 will change up to 10.0.255.255. Next second octet will change like 10.1.0.0 3.0.0. So finally you get 10.255.255.255. Done. Okay. So this is total 10 dot network range. 10.0.0.0 to 10.255.255. In between total how many IP addresses will be there? Yes. Total how many IP addresses in between? Yes, please. Is it
63.
class? Is it class
Is
A?
it
No?
760?
It's a class A network, right? So each network of class A, how many IP addresses? Just before we have discussed, right? For class A, per network, how many IP addresses? 16,777,216
16, yeah.
IP addresses actually. Yeah. So in between, we have 16,777,216 actually. But from this, two IPs are minused. So which two IPs are minus? The first one it cannot be used actually. The last one. So first one, it is only for identification. We call it is network ID. The last one is broadcast. So we call it is broadcast ID. In between network ID and broadcast ID, in between all IP addresses we call usable IP addresses, or we can call valid IP addresses. So two IPs are minus, we cannot use. One is network ID and broadcast ID. So network IDs are identification. Like these all IP addresses will be identified by network ID. If device is having 10,000 network ID, then the device is maintaining these all IP addresses. If we have only 10.1.1.1, then it is only one IP address. It's called a single host. It's a one single IP address, that's all. Correct? But if your device having 10,000, then it is maintaining all these 16 millions IPs are maintaining. Because these all IP address comes under this ID, right? This is for identification. We call it as a network ID. So like this, tell me 19.8.2.9 is IP address. What will be the network ID of this IP address? Yes, what will be the network ID of this IP? Please. Network ID is 19.0.0.0. Broadcast ID 19.255.255.255. In between all IPs, what we call
Valid IP ID.
Valid.
valid IP address. Yeah. One more example. 186.186.19.20.20 is IP address. Agree? Network ID, please.
186.0.0.0.
186.0.0.0 is not network ID. They're wrong.
186.19.0.0.
Right. So how to identify network ID is the main point actually.
Because this IP belongs to
Before
class B.
Correct. So before identifying a network ID and broadcast ID, first identify this IPs belongs to which class. So this IPs belongs to which class?
B.
Class B. Remember class B network portion and host portion? Tell me. First octet is N. Second octet,
So network.
network. Third octet,
Host.
host. Fourth octet, host. So in host portion, if you make it as zeros in host portion. In host portion 255 in host portion. So zeros in host portion is network ID. 255 in host portion is broadcast ID. Don't change the network portion. As is we can write 186.19.0.0 is the network ID. 186.19.255.255 is the broadcast ID. Get it? So in host portion, make it as zeros. In host portion, make it as 255. Then you can get network ID and broadcast. Even for class A example also is the same. See, for class A, first octet is network, host, host, host. In host portion, you make it as zeros, network ID. In host portion, all 255 is the broadcast ID. So 186.19.0.0, what we call it is?
Network ID.
Network ID. Then what about 186.19.255.255 is what? Broadcast ID. Then what about in between all IP addresses we call?
IP address.
How many valid IP addresses in between? Class B. Class B.
65534.
65,536 minus 2. 65,534 is in between actually, right? Yeah. Why minus 2?
Broadcasting has
Host
been
and broadcast.
One for network ID, one for broadcast.
Yeah.
Last example. 192.168 192.168.9.10 network ID, please.
192.168.9.1.
192.168.0.0, right?
No.
No,
9.0.
9.0.
Why?
Because class C has 3
Class
networks.
C has three.
Yes. So because the class C, so class C having first 3 octets are network and last is a host, then host portion make it a 0. So network is 9. What about broadcast ID?
255.
9.255. In between, all IPs are
Valid IP.
how many valid IP in between?
56, 54.
56 actually,
254.
254.
Plus
Yeah.
2.
So can I use 192.168.9.0 for computer?
No, sir.
No. Can I use 186.19.0.0 for computer? No, network IDs cannot be used. Broadcast IDs cannot be used. Only in between of network ID and broadcast ID. So valid IP address will lie between network ID and broadcast ID. So what will be the first usable IP address in this class C example?
92.
168.9.1.
9.1 is the first usable IP. So this first usable IP generally we reserved for router IP as a default gateway. It is not a rule. You can use any IP address to assign a router IP. From 9.1 to 9.254, out of 1 to 254, any IP address we can assign for router. But the recommended is first usable IP is a universally everyone is following the standards actually. Even if you check your computer IP address, IP config, see what is default gateway here? 192.168.1.1 is a router IP. My PC is 1.3 is PC IP. So even if you check your computers also, first usable IP will be there actually for default gateway. Clear? Any doubts? Yeah. Class A, first octet, network and host portion.
Sir, this
Yeah, please tell me.
Yeah, Class A, Class B, Class C, Class C. These three we have to remember, sir, or any
What you have to remember?
first comes network, then host. Second Class
That is
B.
standard, yes. N, yeah.
Resistant.
We remember that, yes. IP address with all bits as zeros in host portion. IP address with all bits as ones in host portion. Any dots? All good. So this is all about for today. This is how we can understand about IPv4 logics. Still, we have to discuss some more logics in IPv4. We'll continue tomorrow, and we'll try to complete IPv4, and we'll continue with IPv6 also. So that is what our upcoming plan. Okay. Thank you. Have a good day.
Sumant here. I just joined late today. I requested access for the recorded session.
You'll
Can you
get it.
just?
Yes.
Yeah,
We'll get it.
yeah. Thank you.
Quick question, Balu. Do we get these slides? Do we have access to these slides that you're showing us?
Slides we don't have access, but I'll arrange some web links. So through web links you can access the same.
Oh, okay. Appreciate it. Thank you.
Please remind me tomorrow. I'll share it. Okay.
I will. Thank you.
Yeah.
Sir, could you please share your WhatsApp or any contacts?
Sure. I'll create the group and share the link. Okay.
Yes, sir. Thank you.
Okay.